Okay, so here we are for our second LinkedIn Live brought to you by Kentik. So we're really excited. This has been a really fun thing to do. Just have these, nerdy conversations and really just talk tech and some of the things that Kentik is working on, but some of the things that's going on in the industry. So a lot of fun. Glad that you're with us today. Today's LinkedIn Live, our title, if I read it off my notes, is The Role of Generative AI, that's artificial intelligence, and Large Language Models, or LLMs, in IT operations. So some interesting stuff as far as I'm concerned. Now, the reason we're talking about this, there's been a lot of talk about AI and how it's changing technology at a fundamental level. I mean, it itself is a changing technology, but it's changing the entire world of technology at a very fundamental level. And we're already seeing the application of ML, AI workflows in certain segments of IT operations. So I'm thinking cybersecurity, and also in observability, and then what Kentik does, network observability. But so much of what at least I've been hearing is kind of speculative, to the extent that I wonder how much of this stuff is actually real. It's very, very interesting to me. I love reading the blog posts and watching the videos, but how much of this is real? So joining me today is Christoph Pfister, better known as CP. He's the Chief Product Officer at Kentik. And we're going to be addressing very specifically the impact, the role of generative AI and large language models, and the role that they can have and maybe are already having on IT operations today. So, CP, thanks for joining.
Hey, Phil, great to be here.
Awesome. So, before we get into the meat of the technology, before we get into what the role of generative AI and LLMs are, or what the role is in IT operations, I think we need to level set and get a baseline definition of what generative AI is, maybe apart from general AI, and what large language models are.
Cool. Well, so certainly LLMs and Gen AI are the hottest ticket in town right now.
Yeah, big time,
so,
big time.
we have to talk about it. Let's try a gentle introduction. So, of course, generative AI, and LLMs are closely related. Both are subsets of artificial intelligence. Both use neural nets as an example. Both are loosely modeled off the human brain, believe it or not. But Gen AI is a bit broader in the sense that it's able to generate different media types. So text for sure, but then also pictures and images and other media as well. LLMs are a bit more focused on generating human-like text, and they're trained on a huge corpus of text. But of course, I'll say this a few times, this space is moving very fast and the lines are already blurring. So for example, OpenAI, the company, just integrated DALL-E, which is used to generate images, with ChatGPT. So now you can go to ChatGPT and say, hey, I want to see something, and it'll generate the image. So, that's pretty cool. But again, the lines are already blurring. So what do LLMs actually do? So in essence, they've taken 4 billion or so pages from the web, alongside some books and some other content, and they're just like making ground beef, in that they have ground up all this knowledge to find out the statistics of everything that has been said on the web over the history of time. And so when you ask an LLM something, its mission is to try and produce reasonable text based on the statistics it saw in its training data. So it produces answers that make sense. They may be fact, they may be fiction, but it's put together in a way that makes sense for us humans. So, it's in a way, it's feeding us back things we put on the web, basically. So, yeah.
So what you're talking about, though, and specifically is, you mentioned OpenAI, and then the internet, the web as its data set, and that's what we're using to train the model, right? That's not necessarily all LLMs, though, is it? And as far as like the history of natural language processing, you can use anything as a data set. It's just that we're using the web now, and ultimately, like you said, we're trying to elicit some sort of answer or some sort of response that makes sense. I think that's the key there, right?
Absolutely.
Yeah, to a human being on top of that. So, I mean, because I was thinking, we've sort of always interacted with computers using human language. I mean, you think about the very first computers, you put like go-to commands on your Commodore. Those weren't the first computers. Those are the first computers for me in the 80s. But you put a go-to command and you're kind of doing your thing or you're writing. I mean, you're telling a computer what to do using a kind of human understandable language, sort of, right?
That's a very interesting point. In a sense, this becomes a new linguistic interface, right? We've had GUIs for a very long time, graphical user interfaces, and now we have a linguistic one. And I think that is one of the great initial use cases, especially in our space, which we'll get to here in a bit, observability. But maybe let's spend another minute on talking about how these LLMs do what they do.
Okay.
Because they've been trained on a huge body of text. You can add to the training by fine tuning it, which is one of the ways of making things smarter about the network, as an example. Mm-hmm. But in a sense, an LLM always picks the next word based on a model that computes probabilities from the training body it has. And so it has, these knobs, they're called weights or parameters, and mm-hmm. they have been tuned well enough that, for most of the things you throw at it, it produces magic-like results. So for example, GPT-3 has 175 billion of these weights, and it has been leaked, although not confirmed, that GPT-4, the latest model from OpenAI, has 1.4 trillion weights. And so, in the words of Stephen Wolfram of Wolfram Alpha fame, an LLM is just adding one word at a time. And that sounds pretty simple, but in fact, it's pretty complicated. So.
Yeah, and I was doing some research, and it seemed like there were progressions. There were these big steps that occurred over the last few decades, and ultimately leading to what we're doing today, where there was this idea of just dictionary lookups, where you're looking at what does this word mean, and then trying to find and then ultimately like a probabilistic method where you're trying to when I'm chatting on my phone, and then it predicts what my next word might be within some realm of confidence. So there was a probabilistic, but now we're talking about an entire context. We're like looking at an entire body of work. And I know one of the things I've used like ChatGPT for is summarizing a text, right? So it's looking at that much more holistically, not holistic like in the medical, but holistically like the whole thing, and then generating something from that, which is yet another level. So there seems to be an element of almost logical reasoning, an ability to even interpret nuance and human nuance, right? So I have to imagine an engineer sitting at a prompt trying to interact with the platform. There's going to be different ways that different engineers prompt it, and then the system has to interpret what is the meaning here. So it's a little bit, it's very interesting to me. So what are some of the different examples of, I mean, you mentioned that there are now these kind of like plugins with ChatGPT and DALL-E, and we could just see how that's going to expand as we incorporate multiple forms of these LLMs and generative AI platforms together. Because I mean, when I use ChatGPT, it's not really computing anything. It's going out there and looking for information and then giving it back to me, right? It's not gonna spit out like an OSPF graph for me and then kind of figure it out and look at the shortest path and calculate it for me. So it really is a way to interact, I think, with the data, right?
Yeah, but so again, it's all about the probability of the next word, and there's ways to tune that, and there's ways to prompt the model to give you a better answer if it doesn't do it the first time. So you can tell it to do it in Shakespearean terms, or talk like a pirate, or and it'll pick these things up. It's quite amazing.
Yeah.
But you pointed out something which is interesting, which is LLMs are really not good at computations, right? So if you ask it, I don't know, what date was 10,000 days ago, it just won't be able to do it. And even like simple math, multiplication, sometimes it has problems because it just looks at the probabilities of the next word or the next token in AI speak. But of course, people are smart, and so the OpenAI folks have just introduced what is called plugins. And so there's a plugin for well, the DALL-E stuff. There's plugin for Wikipedia if you need more recent knowledge, but there's also a plugin for computation. So, for example, Wolfram Alpha, which is well known for this kind of stuff, has a plugin now, and so you can ask the model all kinds of complicated math questions, and it will reach out to Wolfram Alpha and get a response back, and then feed that back to you. So there's like it's moving at the speed of light, basically.
Yeah, clearly. But ultimately, it really boils down to a mechanism to interact with an underlying data set using my own language and my own nuance and my own whatever. There was a scene in, I don't know if you like Star Trek, CP, but there was a scene in Star Trek 4, The Voyage Home, where they go back in time, of course, because there's always time travel in Star Trek. They have to do that at some point. Anyway, Scotty and Bones are in some manufacturing facility, and they're trying to get transparent aluminum to be made. So they talk to the guy that runs the place, and they're trying to interface with the computer, which is an old computer with a CRT manual. And the guy from the past hands him the mouse, and he's like, "No, this is how you interface with the computer." And Scotty starts to talk to the computer like, "Hello, computer." I'll never forget that scene because I always thought like, "Hey, that's how I want to interface with my computer. I just want to talk to it." Just like another Star Trek illusion, in Star Trek: The Next Generation, I always love watching Geordi LaForge, Commander or Lieutenant Commander, whatever his title was, just say Enterprise, or computer rather on the Enterprise. Computer, what is this? And just interact with it using his own language, and then getting back information, and then getting back also computational information, technical information. But ultimately, it's us interfacing with a data set, and so these plugins, and then the way that the underlying data set is really the critical piece. And then the this natural language processing, and then what we're going to talk about shortly, natural language querying overlay, is that interface, that abstraction between us and doing that, as opposed to sitting at a command line or sitting at a, like you said, at a screen and going.
Yeah, 100%. I agree, and there's I think there's potential for a whole new era of us interacting with the machine. And I don't know if you've seen some of the recent things that got posted around GPT-4, where you can ask it something, post a picture, like which wrench do I use to move my bike saddle, and it'll give you an answer, and you go like, man, that's pretty amazing stuff. But
is accuracy still a problem with that kind of thing? Like, is it giving you the wrong answer for the wrench that you should use?
That's always a challenge, because again, the thing has been trained to spit out the next most probable word. Now, there's ways to tune that.
Okay,
it's called temperature, and so if you have a temperature of 0, it will always pick the most probable next token, roughly equivalent to a word, based on its calculations. If you move the temperature up to 1.1, 1.2, whatever it may be, it picks a bit more interesting words that are further down in kind of the table.
Okay.
And I've seen some experiments where, at 1.5 or above, the model completely hallucinates, meaning, it spits out good sentences, but they don't make any sense. And you really have to make sure that, for the important stuff, you verify accuracy.
Yeah.
So maybe that brings us to kind of our use cases and stuff, which, we can't have the model hallucinate for what we want to do, but we'll talk about that, I guess.
Yeah, and I've heard you in meetings talk about that term hallucinate or hallucinations with regard to LLMs. Can you describe a little bit more what that means? Now, you mentioned that that what it is it's a manifestation of having a high temperature, and so it's the AI or the LLM choosing within a realm of probability. Does that mean that it's a lower probable, or rather lower probability, that this is what you're expecting as the human interface person? Is that, what does that mean exactly?
So, if you take a simple example.
That was a clumsy way to ask, by the way. I'm sorry.
Yeah, it's fine. We're having a dialogue here. So, if you take just a basic sentence, I have not heard from. Okay, so the model will look at kind of this chain, the set of tokens, and based on its corpus of text and the probabilities it has calculated will pick the next word. And again, if the temperature is 0, then it means that it'll pick the next probable word that it calculated. If the temperature is higher, there's like a list of words that have lower probabilities, and so it'll pick one of those. And so what it means is that if you ask ChatGPT to write an essay, if you have it at temperature at the low temperature, it will produce very boring content because it just picks the probable thing. If you put the temperature a little bit higher, it will get a bit more interesting, a bit more creative, and that's good for essays, but it's not good for network observability.
Yeah, understood. So there's a risk there, is what it is.
Yeah, right.
Yeah. So then, if this overlay, the ChatGPT or whatever other LLM we're using, is the interface between the underlying data, does it matter what the underlying data set is? What I mean by that is, here we've been talking about ChatGPT, which uses the internet up to a certain year, and that's fine. But you can have a completely different data set being the data that you're interfacing with. So if I wanted to just, does that make sense?
Right. Well, I mean, this corpus of data that these models have, and they all have, a little bit of a different kind of tune, and maybe we could talk a little bit about some of the models that exist out there and their differences. But, you have to assume that it's been trained on a ton of stuff. Now, will it have been trained on the specifics of a network topology, as an example? No. And so that's kind of, some of the things that we could add potentially as, as kind of the fine tune, right? Yeah. Where you give the model additional, data for it to be able to look at and say, well, this is, what I'm gonna produce as an output. But I don't know. I mean, you can try it, a number of different ways. It knows a lot of stuff, and yes, there's some knowledge cutoffs, like date cutoffs and things like that. But again, these get solved with the plugin type concept. So
so there's multiple facets here. We're talking about the ability to interpret language and then be able to respond in kind, but also to add that additional, train the model in terms of network information. Bringing it over to the IT operations discussion, whether it's network or cloud, whatever, just technical stuff. And we're able to add in that in the form of a plugin or in the form of however else we train the model, so that way it can not only respond language-wise, which is important, that's the whole NLP part, but also accurately based on the technical information that it's derived that answer from. So there's really multiple facets here. That's a lot. So, I mean, that presupposes that the actual prompting is very important, right? That the actual way that I enter in my case, English, my question or my request is very accurate, and one subtle difference could negatively, adversely impact the result, right?
Yeah, so there's different techniques that you can use. So let's go through them real quick. So there's what is called zero-shot prompting, meaning there's no additional data other than the question or the input that you provide the model. So an example, you ask the model to translate from English to French and then prompt it with cheese, and it'll come out with fromage.
Yeah.
I didn't have to look that up. I have.
Yeah.
So then, that's zero shot. One shot prompting is there's a single example that's provided. So you ask it again to translate, and then you give it one example of the word, of a translation. Like you give it the cheese fromage thing, and then prompt it with something else, and so it has one example. And then there's what is called few shot prompting, where you give it a labeled set of examples as part of the prompt. And what's really interesting is, and we've experimented with this a lot as part of the NLQ work that we've been doing, you always have a choice between fine-tuning, training a model, and prompting it. And there's pros and cons to each. Like if you do fine-tuning, you basically have to provide, a labeled data set of thousands or tens of thousands of examples, right? and that's long, and you have to, prepare the data and all that kind of stuff. Well, it has been shown, and also that's been validated by our example. If you give the LLM a prompt that has like 20 to 50 examples ahead of the actual question, it produces results similar to a trained model that has been trained with or fine-tuned with a data set of 10,000.
Really?
And so, the prompting, not only is it faster, it allows you to iterate faster, it's also, much less challenging than training a model. Training a model is, pretty hard. Mm-hmm. You have to know what you're doing. And of course, there's the cost. And so, there was this one concern we had about what is called context windows, meaning if you have a long prompt, with many examples, there's only so much, so many tokens that a model can consume, and it's changing all the time. But initially, the OpenAI models, I think, had 4,000 token. They're now expanding to 16,000. There's a model called Claude, which has 100,000 context window. And so, one of the interesting things is that it's almost like you have a new Moore's law for AI, meaning things are evolving so fast and so quickly that, something that might have been impossible yesterday, may just be very easy to do tomorrow. And so I'm telling my team all the time, if you think something's not possible and, we need to find another solution, let's just, count on the fact that this space is evolving so quickly and the progression is so fast that, things will be possible soon that may have been impossible, yesterday. So.
Yeah. I want to get to the big picture of how all of this, what it all has to do with IT operations. That's important. I mean, that's the whole point of why we're talking today too. But I'm very curious on how we train a model in the context of what we do in network observability. I know that this is something that we're working on at Kentik, and we're going in this direction, which is really, really interesting to me. But I mean, we're starting with the actual LLM and the ability to interface with the data. But the whole point that we at Kentik would want to interface with the data is so we can get some sort of technical information, some technical answer, insight, anything like that. So how do we train a model? What is the data that we would use in an IT context?
Right. So it's interesting. There's actually an IT operations model out there, a fine-tuned model. It's called OWL, O-W-L. And so, we've looked at it, and it's pretty basic. Again, it may evolve fast. I don't want to dismiss any of it. But for now, for example, if you have a question about, the IT operations management space, as an example, you ask the model, can you tell me how to monitor and manage logs in distributed systems? Well, it will come back with an answer that says, well, you got Elastic and Splunk and, some other tools that allow you to do that. So it's pretty generic stuff. It has been trained on pretty generic questions. Now, as we look at where we can add value to customers quickly and immediately, we think that the best shot initially, anyway, is to help people with making their lives easier, making our tools, our solutions, our network observability solutions more approachable. And we think LLMs can help big time there. So Kentik being about network observability, maybe transition a little bit to our space here.
Yeah.
Basically means you look at all the networks, all the telemetry, you're trying to figure out what's going on with the network in terms of capacity, in terms of performance, in terms of, God forbid, DDoS attacks, in terms of traffic egressing where it shouldn't because it has cost and so on. Mm-hmm. That's kind of what we do for customers. And to do this, we have this concept of open exploration, which allows customers to spelunk, no pun intended, in their data at will, more or less, and figure out in real time what's going on. We call that ask any question, right? And so we facilitate that with a part of our product, which is called Universal Data Explorer, which is essentially a query tool, right? It's very powerful. Mm-hmm. But of course, there's a learning curve associated with that. And typically, only a small percentage of users in a company know how to use it well. So wouldn't it be nice if we just could allow any engineer to ask any question in natural language? For example, show me the top devices on my network per CPU, or show me all interfaces with high utilization, or pick your favorite example. And then the LLM translates that into the actual query and executes it, and really gets back the answer. So that's kind of a very near term, I think, value adding step that we can provide as a network observability provider, basically.
And that's across the board for teams. I mean, what you just described would be applicable to somebody who's a network engineer, an SRE, cloud engineer, even an application person who's kind of looking at some of the underpinning technology that their application is riding on. I mean, anyone, help desk people. It's ultimately all that data from everything that's going on is there sitting in a database. And so you just ask the question in the way that you need it, right? Like as if I was literally checking boxes in Data Explorer to check the filters that I want. All the data is there. So it really is, I don't know. It's a great way, it seems like, to break down some of those silos that we might have in IT operations, which I know we've been talking about for a long time, breaking down the silos because of DevOps and all these things, but there's still silos out there.
Yeah, I mean, look, it's yeah. I think that's the ultimate promise potentially for LLMs, to break down all these silos by providing this. I'm going to use another foreign language term, lingua franca, like the Esperanto language of IT operations. Management, and allow any admin, no matter their background, system, database, network, to basically look at any part of their estate, whether that's network, systems, databases, whatnot, and get an answer back that's appropriate to their background and skill level.
Right.
I think that's a grand vision, and we should put it out there. But I think it may be a little bit further out, because as I said, like, to train the models on kind of the broad space that we're in, number one, and number two, we all know, Phil, you've been a practitioner maybe longer than me. All these networks and all these environments are snowflakes, right? And so you can train the model in some generic things, but then how do you make sure that it's responding to the specific challenges at hand in your network? And that's something that I think over time we can figure out, but we will have to work at it and hard.
Yeah, I'm picturing the underlying data set that I would be interacting with as a network engineer, SRE, whatever, today, and it's not like flow from my closet switches, and that's my data set. I mean, it's a tremendous amount of stuff that's involved with application delivery today. You're thinking about container information and cloud provider information and metrics from all your devices, and then more qualitative information like security tags and customer names, stuff that you just kind of scrape off of spreadsheets, and all of this stuff. Some of it's just completely subjective too, right? And how do you put that all into an algorithm? How do you put that into math so that way you get an accurate an answer back? Now, I've done quite a bit of research on natural language processing, NLP, but you like 3 times now said natural language query. You said NLQ. What's the difference? Are they the same thing? And query is just the manifestation of?
I think it's maybe specific to how we, and some others, not many, understand observability, right? Observability is about exploring your data at will and in real time, and we do that, well, for right or for wrong, we do that through a query language. And most tools out there have one that claim to have any part in observability. Many network management tools don't have them. But if you look at kind of the APM space and Honeycomb, which was doing similar things to us in the APM and application space, they have a query language. And so natural language query processing is just an expression of, hey, we take natural language and we translate it into the query language of the tool at hand. And, in our case,
Right.
it's Kentik. And, we're getting pretty good results. In fact, they're that good that we just put out a private release to our customers.
Mm-hmm.
So we think the accuracy that we've achieved now is good enough for customers to take a spin and give us feedback. And we're always learning with our customers. We do have a bigger vision though, and if you think about it, you put in a query, and that's only the first step, because if you string together multiple of these questions, that's what you need to have a troubleshooting journey, right? Troubleshooting is what? You look at something, you go, oh, that doesn't look right. Let me, figure out what's going on. And then you get the result, and then you kind of get to the next step.
Clue chaining.
And so, take asking a question, analyzing the answer, and then, this is repeated until you come up with eventually the root cause and the solution. And so we've been working on this concept we call a journey, which does exactly that, meaning it gives you a dedicated area and workspace, saving your questions and answers as you go, of course, bringing in all the telemetry that we typically take in as Kentik, which, is of course flow data, VPC flow, SNMP, streaming telemetry,
right?
Allowing you to correlate amongst these things and, be interactive and iterative as you drill down into the problem space. And next time we'll figure out how to do a demo on one of these LinkedIn Live streams, because it only comes to life well, I think, in a demo. But that's one of the things we're looking at next. And then we also think that as you ask these questions, wouldn't it be nice to kind of predict the next question a user or customer might have? Now we have hundreds of customers, many with hundreds of users, asking Kentik platform hundreds of questions every single day. And so that means there's a huge data set which we want to use to kind of suggest and predict the next question. Think of it as the Amazon thing of, hey, customers like you have also bought XYZ, right? If you're looking at, what's the famous example? If you're looking at Pampers, you suggest beer or something. Right. And so, think of that as, something very interesting to do potentially with network observability and network observability data.
That is really, really interesting. I mean, you're literally describing that scene from Star Trek that I mentioned, where I'm interacting with the data, using my own language and able to, approach root cause analysis in a more programmatic way. The old school method of manual clue chain. By the way, CP, I don't want to knock manual clue chaining, because I like it. I was an engineer for a long time, and it's like a puzzle and a process and I found the solution. But I have to imagine that the CEO of my company, I'm at some hospital chain. He's like, Phil, I'm glad you're enjoying yourself troubleshooting, but I'd like an answer now. Like, that's great that you're having fun. So really, we're talking about reducing the mean time of resolution. We're talking about having a deeper understanding of how all these different individual data points relate to each other. Because I have to imagine it's like, well, why is my Chicago office slow? Well, I switched my data center A to data center B from Cincinnati to Singapore and swung my BGP peers over. Well, what does that have to do with anything? And I have a platform that can identify things that are correlated that I, as a human being, may not have been able to see without a team of MIT PhDs working for me. So this is just tremendous. And I understand that we're at the beginning of that journey, but the fact that we're on that journey, also using the term journey for our product, is really, really neat.
Yeah. I mean, you and I both know that sort of this, concept of root cause analysis has been,
which is where I was going. Exactly.
The holy grail of our industry for, I don't know, decades, but at least for me, and you tell me your experience, I've yet to meet a customer or user who says, I'm super happy with what I have. And so there's still a huge potential to move the needle there. And I do think that, LLMs trained on the network have the potential to help with this deluge of data. Now, as we've discussed, it's not going to be easy, because all these networks are snowflakes, and Where do you start with the semantics and all these things, many concepts, but many concepts are generic, right? Topology is generic, routes are generic, paths are generic.
Yeah.
And so I believe there is really a way for us to significantly move the needle for the industry. And that's what we're working on very hard right now.
Yeah. I think the holy grail might be the automated root cause analysis leading to an automated remediation. I have heard folks just in recent days talk about that. That scares me, pushing config and letting the thing just do its thing. But
but it's not that. I mean,
decades.
I kind of try to weave it into the conversation, but it's very important that we think of this as augmenting human potential, right?
Yeah.
It's not replacing anything. I think the human is still like way above and beyond anything as it relates to intuition about some things, and managing IT is part of that.
Yeah.
But helping the human to move faster and giving them hints is part of the story here. And so then that's exactly where the remediation piece comes in, where you may have tried it, but you can ask ChatGPT today to give you a config snippet for, I don't know, a Cisco router, and you give it the type, and yes, it may be 2 years old, but these things don't change that often. So it will give you an option to reconfigure a router and the actual code to do it. Yeah. And so, from analysis to remediation, it's actually a pretty small step. Again, if you think of it as the co-pilot, not like, the model actually doing it, but giving you a way to do it and a suggestion. And then you can decide whether you pull the trigger or not. And I think, the speed and just the breadth of how we can, deal with problems will get a whole new, we'll go to a whole new level. And that's the exciting part.
Yeah. Yeah, and that's the heart of what we do at Kentik. I know, just having done about 100 presentations on what we do. It's all about solving a network operations problem, or really IT operations, because we have a lot of folks that are not specifically network engineers, but we're solving an operations problem and augmenting the engineer so they can do their job better, solve problems faster, get more insight that would be more difficult to get just in a small team. So this fits right into it. And I do have two, the concerns. I hear about bias in AI a lot, and I'm also worried about accuracy, because we're talking about ephemeral information. We're talking about IP addresses on containers that don't exist tomorrow. We're talking about subjective information. We're talking about, like I said, outdated spreadsheets with customer like circuit IDs, and how do I? So obviously, garbage in, garbage out, right? The underlying data set needs to be accurate. We don't want those hallucinations, and I'm also concerned about the bias thing, which maybe I don't understand quite what that means. But what do you think about those two areas?
I think the bias thing is potentially less of a concern for us, because
really, okay.
Well, I mean, we're not asking the LLM to write a historical essay, right? Okay. Which may be biased because of the training set, really. I mean, that's a challenge. We're asking it to output queries. And so, by putting the temperature at the lowest possible level, we think that, hallucinations are less of a concern.
Okay.
At least that's been our experience. So this, temperature concept is really important. But then, yeah, you're right. I mean, there's this whole notion of, what the LLM has been trained of. I'll give you an example, which I found interesting the other day. So assume LLMs, came to life in the time of Galileo Galilei, right? Like way back, 1600s. We had large language models that we have today. And you asked the model a question about the universe. and the model would have told you, because all the corpus of, well, training at the time, was saying that, the sun is evolving around the Earth. Yeah. It would have told you that, and it's obviously wrong.
Yeah,
because the corpus it has been trained with was wrong, and so this is the whole notion of bias and accuracy. So it there's some interesting challenges, I think, but they're less. I think they're a little bit less pointed, in our domain. It's the generic, Gen AI, in the sense of general AI, not generative AI, that has to watch out for these things. And there's regulation coming out. The president just yesterday or the day before signed a huge executive order around regulating AI, and I think we as an industry will be able to overcome some of these challenges, but no denying that they exist.
Yeah, but to a lesser extent in the realm of IT operations, as far as we are applying. So, that's interesting. I hadn't thought of it that way. But what about the accuracy part, especially as we get toward that more long-term vision of producing an insight that we didn't otherwise have, or a possible solution? What about the accuracy part?
By iterating and working with customers and using the right prompt techniques, and eventually using fine-tuning and training, we believe we can get to a reasonable accuracy. And when I say reasonable, I'm keeping it vague, because 100% will be challenging, but what's good enough? Is 90% accuracy good enough if it really speeds you up? And some of the things that come out of the model and the exploration and the analysis you're doing, you look at this as kind of the human and go like, this doesn't make sense, but it has helped you move faster. And so I think there's a trade-off, and we think that the trade-off weighs heavily towards using these kinds of techniques, and accepting that sometimes the model may output a little bit misleading information, even like in our realm, right?
Yeah.
But if you look at ChatGPT, there's a little fine print at the bottom. It says always check.
Yeah.
And so I think what you have to do as an industry is to use these models today in your app with always a perspective of making it undoable, meaning not triggering any action that you can't do a Control Z on,
right? Yeah.
To speak loosely. Yeah. Will that change over time? I think so, but for now, that's
Yep.
I think the right balance between pragmatism and caution.
And ultimately, everything is iterative, so that makes sense. We want to move forward. One more concern that I didn't bring up, just thinking about it now, is around security. So, I'm going to give the keys to my network over to Skynet. What should I be concerned about in terms of security specifically?
Yeah, of course. I mean, it's obviously a vast field, but I'll give you one example. I think everybody has heard of SQL injection.
Yep.
And well, there's a thing called prompt injection now with these large language models. So if you build an app on top of an AI model, and let me use this stupid simple example with translation again. So you have an app that translates English to French, and then the person using the app, instead of doing the translation thing, says, hey, I changed my mind. Please, instead of translating, do X. The model will take that input and potentially do X instead of doing the translation. And so, as you build these apps and these interactions with the model, you have to catch these things, and it's not easy. People are already trying it, and so you have to make sure that everything, again, you do with the LLM today is non-destructive, and you have the Control Z option.
Yeah.
But yes, that's one of the challenges for sure.
Yeah, it sounds like ultimately what we're trying to do with all of this, with regard to the application of generative AI, large language models in the realm of IT operations. Again, it's the focus on operations and augmenting or helping human beings to do their jobs better, to solve problems faster. And really, what we're doing at the end of the day is providing a conduit for human beings to access data. So it's usually in the form of an application, and it's usually over an internet, over the internet, excuse me, considering where applications live today and how they're built. So that's a tall order considering the data set. You mentioned volume of data, but also the diversity of data and the fact that they're not static. They're not all static configurations. So that's a tall order.
That's right.
You also mentioned the future ultimately leading to kind of a programmatic root cause analysis, possibly even with a high degree of probability around a potential solution. I mean, that is really cool. That is really speeding up this entire process of solving problems and improving IT operations in a very meaningful way. I mean, that's something that we've always done at Kentik anyway, but obviously when you go through Data Explorer, clicking boxes to create your filter, super, super, super powerful. But like you said, it requires a certain level of knowledge and understanding of your particular field, right?
You're right. Really cool. I think there's, really so much potential to move the needle for observability and then more broadly, IT operations management practitioners, because it can help to speed up troubleshooting. It can help to get more precise, to pinpoint the needle in the haystack in the middle of a hurricane, aka an outage. It can help people to get rid of the drudgery. I mean, making them more efficient, on the important stuff. But it should always be in the spirit of augmenting the human capability and intuition, because I don't think any machine anytime soon will match the context and capacity that engineers have to make a judgment call about what a system should or should not do. And so that's kind of the spirit that we're innovating in. And as I said, we don't just talk. We have a private release out to our customers on this stuff. And get feedback and iterating towards the future with them. So I think it's cool. It's a great time to be alive.
A great time to be in network observability too, right? So
in general, yes.
Right. Well, we're pushing an hour, so I'm going to close us out for today. I'd love to talk to you again about this stuff, especially as we're developing and training our models. And I have a lot more questions actually on how you train individual customer models. If you're going, lots of stuff that came up during this conversation. I'd like to talk about. So, but for now, CP, thanks for joining today. I really appreciate it, and thank you also to our attendees for hanging out with us. And as we discussed, some of the things that I at least think are the most compelling technologies today, especially how we may be able to use those technologies, generative AI, large language models, to improve IT operations. Hopefully you got a sense of what we're doing at Kentik as well. So before we wrap up, I'd like to just kind of repeat where what CP just mentioned, that Kentik is currently working with a small group of our customers on a new product based on exactly what we've been talking about. The application of generative AI and large language models to networking is where our realm is, but we really think in a more broad sense to the overall IT operations, considering what network encompasses today. So we are working with them to get feedback, to test accuracy, and ultimately fine-tune that function, that underlying function, to make it as helpful, as useful, as meaningful as possible to actual engineers, practitioners using our platforms. Really cool tech, really excited about where we're going with it. But if you're interested in learning more about Kentik as a platform, what you can do is visit our website, kentik.com. You can sign up for a free trial, and we have unlimited use of the platform there for 30 days. You can also read some helpful blogs, watch demo videos. We have a podcast that you can check out. And you can always reach out to a Kentik representative as well and go from there. So for now, thanks very much for joining, and we'll see you soon.